Hey. So let's talk about trigonometry, exam one, test one, module one, review. So this is what your trigonometry exam one test will look like. So let's go ahead and get started and let's do this. So right here it says find the complementary and supplementary angles to 4 pi over 11. So this is in radians. Okay, nothing wrong with that. So remember that complementary means that they add to 90 degrees. Or in radians, they add to pi. Supplementary means, good old geometry right here, that two angles add to 180 degrees. Sorry, 90 degrees is not pi. 90 degrees is pi over 2. Almost messed that up already. 180 degrees is pi. Okay? So, this is our given angle. We need to know what plus 4 pi over 11 equals pi over 2. And down here, we need to know what plus 4 pi over 11 equals pi. Okay, this is really just fraction work. This is like having what plus 4/11 equals a half. That's what dealing with radians is like. So what fraction do we add to 4/11 to equal 1/2? Okay, and then pi is just going to come along for the ride. So our answer should have pi in it, in the numerator. Okay, and then down here, again, it's just like what plus 4/11 will give us the number 1, because that's the number that's in front of pi here. And again, pi is just going to come along for the ride. So if we go to our calculator, because I don't want you doing fraction work by hand, and you have access to a TI-84 calculator for your exam. All you're going to do is take and hit alpha y equals, and you're going to put in the fraction a half, because that's like our 90 degrees. And we're going to subtract the angle that we have from it, and that will tell us what's left. So the angle that we have is alpha y equals 4/11. Hit enter. And the answer to the complementary will be 3 pi over 22. Like I said, pi just comes along for the ride and it stays in the top. So the complementary answer is 3 pi over 22, because 3 pi over 22 plus 4 pi over 11 equals pi halves, which is 90 degrees. Then down here, all we're going to do is take the 1 minus the 4/11. Okay? So 1 minus alpha y equals, grab that 4/11, and there's the other answer. So our supplementary answer is 7 pi over 11. And that's what they're looking for. Because if I take 7 pi over 11 plus 4 pi over 11, I just get pi. Okay? Another way you could do this, if you don't like working in radians, change them to degrees. There's nothing wrong with that. But just know that in the end, you're going to have to change the degrees back to radians. Okay? So remember, changing radians to degrees, all you got to do is take your angle and multiply it by 180 degrees over pi. And then to change back in the end, degrees to radians, you'll take your angle measure and multiply it by pi over 180 degrees. Okay, I'm not going to show that because that's your choice. I'm giving you the information on how we do this in radian style, the straightforward method. Okay. All right. So question number 2, moving on. So the next question we got, it says sketch an angle in standard position. So here we have our multiple choice, and you'll have multiple choice. And then it says, so standard position, and draw an arrow representing the correct amount of rotation. Okay. So that's that little blue guy that's there, even though that's not really an arrow, but neither here nor there. Find the measure of 2 other angles, one positive and one negative, that are coterminal with the given angle and closer to the given angle than any other coterminal angle. So in other words, what it wants us to do is find one angle that is coterminal above that angle and one angle that is coterminal below that angle. Okay, that's what that means. Give the quadrant of the angle as well. So tell us what quadrant the angle is in. Okay, so the first thing is, let's talk about standard form. Remember, standard form, and our angle is negative 62 degrees. Standard form means that you have an initial ray that is on the positive side of the x-axis. You have an initial ray on the positive side, and then your terminal ray either rotates counterclockwise or clockwise. Remember that counterclockwise means that you're dealing with positive angles. Clockwise rotation means that you're dealing with negative angles. So our angle is negative. That means we want to rotate clockwise. And we're going to rotate negative 62 degrees, which would look about like that guy. That's a negative 62 degree angle. So we need to pick one of those 3 pictures that looks like this. My terminal side, my terminal ray is in quadrant 4. And that actually answers the last question of this as well. Okay, where it says in standard position, where does the terminal side of A lie? So you know that the last part is D. We are in quadrant 4. Okay, which is choice D. But for our first guy, which picture matches what I drew? And that would be picture B. That's the standard position. Okay. Now let's find the least positive coterminal angle. And I don't like that they call this the least positive. That's bad vocabulary here because, well, actually, sorry. Well, yeah, least positive and greatest negative, because sometimes the angle they give you is already the least positive. It's misleading, okay? And sometimes the angle they give you is the greatest negative coterminal angle, okay? So I don't like that, but it's what they put there. Really, again, like what I said, what they want is they want one positive angle that's above this, and then one negative angle that's below this, actually this guy, okay? It's not really looking for the least positive and the greatest negative sometimes. So, all right, so let's talk about this. So our next 2 answers. To get the least positive, we're gonna take negative 62 degrees, and coterminal means add or subtract 360 degrees, okay? Coterminal means you're going to add or subtract 360 degrees. Or if it's in radians, it's 2 pi. So since we're in degrees, all we're going to do is add 360 degrees until we are positive, okay? So you just go to your handy dandy calculator. You take negative 62 plus 360, and you get 298 degrees. this is what they consider the least positive coterminal angle. And in fact, that is the least positive coterminal angle. Because to be the least positive coterminal angle, you need to be between 0 and 360. That is truly the least positive coterminal angle. So this is good. Now down here, it says give us the greatest negative. Technically, negative 62 degrees is the greatest negative coterminal angle. But like I said, in the directions, they really want you to go one coterminal angle even more in the negative direction. Okay, so here we're going to subtract 360 one time, even though this really is the greatest negative coterminal angle. See why I say sometimes this vocabulary that they put right here is not very good. Okay, all they want you to do is go one more angle negative and one angle that is positive above around the given angle. That's really what they want. So go to your calculator, take negative 62 minus 360, and you get negative 422 degrees. Again, this is not the greatest negative because this is really the greatest negative. Okay? They just wanted you to go one more coterminal in the direction of the negative. Again, not the greatest vocabulary word choice for that question. But there's all four answers. Here's the standard form, which helped us answer the last question, which was in quadrant 4. And then here is one positive coterminal angle and one negative coterminal angle. Okay? So don't think of these as least positive, least negative, or greatest negative. Think of this as give me another positive coterminal angle that's right next to it. In other words, add 360 degrees. And then give me one more negative. Okay, which means subtract 360 degrees. All right, so there's question 2. Moving on. Question 3. So they want you to convert this from radians to degrees. But we've already kind of talked about that. In order to convert this, all we're going to do is multiply this by 180 degrees over pi. So the two pi's are actually going to cancel out. Boom, boom. So really what's going on is we're taking 2/3 times 180. Just go to your calculator. Again, alpha, y equals 2/3 times 180. Boom goes the dynamite. There's the answer. 120 degrees. Okay, that's what they wanted. That's it. All right, moving on. Question number 4. So right here, they're asking you how long is an arc intercepted by the given central angle in a circle in a radius of 16.81 feet. Make sure that when you are taking this exam, please read the fine print. It says round to the nearest hundredth, because some of these answers you're going to keep exact and some of them they will make you round. Always make sure that you are paying attention to that. Super important. Okay? So we have a central angle of 30 degrees and a radius of 16.81 feet. So if we go over here, we have an equation that tells us how to find the arc length. Okay? And that equation is, if I remember correctly, it is the variable S equals theta r. Okay? So one thing you need to understand about theta up here, this must be in radians. They do not want it in degrees. So that's super important. When you plug into this equation, you got to make sure that theta is in radians. Okay? So double check that when you are using this. And yes, arc length is the letter S. So all we got to do is take 30 degrees, change it into radians. And again, we talked about how to do that. You're going to multiply it by pi over 180 degrees. Or in other words, what's really going on here is you're taking 30 degrees times 1 over 180 degrees. In the end, you're just going to slap pi in the numerator of your fraction. Okay? So we take 30 times, not 300, silly me, times alpha y equals 1 over 180. Scroll out to the side, hit your enter. And so our answer is 1 pi over 6, or you could just call it pi over 6. So now we can find S, because all we're going to do is take pi over 6 times 16.81, and it says to round to the nearest hundredth. So that's 2 decimal places. So come to your calculator, and you're actually going to put in alpha y equals, you're going to put in the fraction, and you're actually going to use pi this time, because we're taking pi over 6 times 16.81. So you actually do need the pi in there. And there is our arc length. Rounded to the nearest hundredth, you get 8.80. If you don't want to put the 0 in, you don't have to, but usually if it says to the 100th, I would make sure that I would have the 0 there so that it can see that, oh, there really is 2 decimal places that I'm talking about. Okay. So, and always a label is good because this is an actual problem in the real world. So that is 8.80 feet. So that would be the answer I put into my math lab. Okay. All right, number 5 is asking about sector of an area, or area of a, no, it's not. So I thought it was asking about the area of a sector, but it's not. So just so you know, question 1 through 4, this was all a part of 9.1. Okay, questions 1 through 4 was all a part of 9.1. Question 5 is when you begin 9.2. Okay. Probably should have been telling you that from the very beginning. But 1 through 4 is all about 9.1. Question number 5 starts 9.2. So here it wants us to actually find some sine, theta, cosine, theta, tangent, theta. Now this is where you're going to need to make sure that you read the directions carefully. When you read these directions, it says that the figure shows some angle theta in standard position. So you can see the blue standard position here. Okay. With its terminal side intersecting the unit circle. Now this is important right here. Unit circle. When you're on the unit circle, remember that means that the radius is all 1. So that makes finding these trig functions really easy. Okay, so we've got this point here, this point of negative 5 over 13, comma 12 over 13. Okay, so it says evaluate the trig functions. All right, so here's what we know. Remember that when you're on the unit circle, and this only works on the unit circle, sine theta is equal to y. Cosine theta is equal to x. Tangent theta is equal to y over x. So all you have to do is fill in. So sine theta, it says it's whatever y is. Remember, this point is made up of x, then y, if you forget. So sine theta is 12 over 13. There's one of your answers. Cosine theta is whatever x is. Well, that's negative 5 over 13. So there's cosine. Tangent, you take the y, which is 12 over 13, divided by the x, which is negative 5 over 13. Now you can go to your calculator or do this, or just remember that we don't really divide. Division is made up. Division is really multiplication of a reciprocal. Remember, keep, change, flip. So what's really going on here is it's 12 over 13, keep, change division to multiplication, flip it. 13 over negative 5. Well, what's going to happen to 13? They're going to cancel out. What am I left with? 12 over negative 5. Remember that negatives, they can fall in 3 different places. So this answers just fine, but you could also have the negative in the top over a positive 5, and that answer is correct. Or you could put the negative out front, which is what I usually do, and then call it 12 over 5. Both of these are still correct, as long as you got the negative either in the top, the bottom, or out front. Do not have it in both places. You know better. All right, question number 6. So we want to know, what are all the answers to these? Okay, so do we get an answer, or is it supposed to be undefined? Okay, so when we're dealing with this, again, we are on the unit circle. So that's important to know. So we want to know, what is sine of 3 pi? I'm just writing this down. Cosine of 3 pi. Tangent of 3 pi. Cosecant of 3 pi. Secant 3 pi. Cotangent 3 pi. Okay? So again, we are on the unit circle, which helps us out. So that's important for us. Okay, now 3 pi. Remember, on the unit circle, okay, here's my unit circle as best as I can draw it. From the starting point all the way around once is 2 pi. So what you need to do on these is you need to find a coterminal angle to this. Because right now, this has gone around my circle once and a little bit more. So remember to find coterminal. And what we're really looking for is the true least positive coterminal angle. So since this is a big positive number, we're going to take 3 pi minus 2 pi until we get a number that is between 0 and 2 pi. It's because we're in radians. So if we were in degrees, we would subtract 360 until we were between 0 and 360. Okay? So 3 pi minus 2 pi gives you 1 pi. So all these answers that are up here are really going to be the same answer as whatever happens at 1 pi. Okay? And 1 pi is 180 degrees. That's 1 pi. And since you're on the unit circle, what is this point? That point is -1, 0. Now you can answer all the questions. Because again, up above, we already know that sine is the y value. So the y value is 0. So sine of 3 pi is 0. Cosine is the x value. So the x value is -1. So cosine of 3 pi is -1. There you go. From here, tangent is the y value over the x value. So 0 over -1, and that reduces down to 0. And they want you to call it 0. Do not put it in as a fraction. It is just 0. Now, when we go over here, remember, if you know these 3, you automatically know all these because all you have to do is take the reciprocal of them. Okay? Because cosecant theta is equal to 1 over y, which means reciprocal. Flip it. Secant theta is equal to 1 over x. And cotangent theta is equal to x over y. So all we got to do is just flip these. That's why I always start with these three, the sine, the cosine, and the tangent, because all I do over here is just turn it upside down. Remember that this 0 is over the number 1. So if I flip that, I got 1 over 0. If you go to your calculator and type that in, this is what's going to happen. And it's not 0 as an answer. See, you get error, divide by 0. Okay? We don't like that. So remember, whenever there's an error on that, we call this guy undefined. So this answer really is undefined. Okay? If you take the reciprocal of -1, remember that this guy's just -1 over 1, you get -1 again. Okay? Because you just flip it. And then down here, we've already talked about this. What's the reciprocal of 0? It's undefined. And there are the 6 answers. We call this a quadrantal angle. Okay, whenever you're on the axes, like 90 degrees, 180, 270 degrees, you're quadrantal. And so your answers are always 0, 1, or undefined, or -1, of course. Okay. All right, there's question number 6, again, coming from 9.2. All right. So question number 7. All right, so you can probably hear my kids in the background yelling, "Mommy needs you." That happens. All right, so right here it says determine the trig values of for alpha. Again, alpha, it looks like a little kind of fishy. It's just another name for theta, alpha. Sometimes we throw in beta. Yeah, so sometimes they'll even put capital letters here for angles. So we just want to find what is tangent alpha. We want to know what is cosecant alpha. We want to know secant alpha and cotangent alpha. All right. So since we are in 9.2 on this one, this is still all about the unit circle. And they're telling us that sine alpha is equal to -12 over 13. And they are telling us that cosine alpha is equal to -5 over 13. Again, because we are on the unit circle, because section 9.2 is all about the unit circle. Okay, they are telling you the point here. Because remember, sine equals whatever the y value is in a point. So we now know that the y value is -12 over 13. Cosine tells you the x value. You now know that x is -5 over 13. Again, you can only pull this kind of information off in a unit circle like that, where the answer represents the y value, the answer for cosine represents the x value. It only works in the unit circle. Be careful of that, because when we get to 9.5, things change a little bit. But right now, being in the unit circle, we can get away with that. So over here, if we want tangent, it's a lot like what we did back on problem number 5. So we're going to take the y value, which is -12 over 13, and divide that by the x value, which is -5 over 13. Again, it's just multiplication. So -12 over 13 times, because division becomes multiplication, flip it, 13 over -5. So the 13s cancel out. And the negative over the negative becomes positive. So tangent alpha equals 12 over, sorry, I wrote 15, should be 5. Silly Mr. Armstrong. 12 over 5. Cosecant, remember that is the reciprocal of sine. Okay, so let me move some stuff down. I don't like the way I wrote this. It's just bad form. So let me fix this. Mr. Armstrong's got a quick fix. Sorry. I want to keep all my answers together, and that's just bad. I don't like separating all that out. Okay, almost there we go. So tangent alpha equals, as we said, 12 over 5. Cosecant alpha, we said, is the reciprocal of sine. So all we got to do is flip this upside down. So it's still negative, but this time it's 13 over 12. There you go. Secant alpha is just the reciprocal of cosine. So we flip that upside down, it's still negative, and it's 13 over 5. And cotangent alpha is equal to the reciprocal of tangent. So flip this upside down, and it's 5 over 12. And there you go. Like I said, if you know the big three, sine, cosine, and tangent, you know the other three because they're just reciprocals. Easy peasy, lemon squeezy. All right, so now we're jumping into 9.3. 9.3. So 9.2 was all about question 5, 6, and 7, the unit circle. 5, 6, and 7 deal with the unit circle and trig. So 9.3, this is all about graphing sines and cosines. This is all about graphing sines and cosines. There's not a lot of these, so no worries, but you got this. All right. So we have y equals 3 cosine 7x minus 5. And they want us to talk about the amplitude. They want us to talk about the period and the phase shift, which phase shift means horizontal translations, moving left and right. Okay? So here we go. When you look at this, before you do anything, inside here, if there is a period change and a phase shift, you got to make sure that this guy looks like this. Your trig function. Just spell it around. So your trig function goes in front, whatever it is, like sine, cosine, tangent, cotangent, so on and so forth. And inside here, it looks like this, because these are the letters that represent the shift. Notice how it's a B and then a parenthesis of x minus d in parentheses. So we need this to look like that, because look, I've got a B and I've got a D here, although this is not the real D. We got to make it look like a number, parenthesis, x minus another number. So what's happening in here, you need to pull out a GCF, okay? So what we're really going to look at here is 3 cosine. You're going to pull a 7 out of all of this, okay? Whatever number is right here in front of x, if you have to pull GCF out, that's the number to go with. And so when you pull that out of 5, you really get 5/7. That's what we need. That's what we have to know, okay? Because now you can see the B and you can see the real D, okay? This is the real phase shift that's going on. So let's talk about this. So the 3 right here, this is our amplitude, okay? Because the A that's in front of your trig function, the number in front of your trig function, A deals with the amplitude. So that means the amplitude is 3. And that's all they want. So you can go over here and you can look at this. See, we know it's not A, but look at the rest of them. Amplitude 3, amplitude 3, amplitude 3. So we now know it's B, C, or D. So whatever the A value is, the number in front of your trig function, that's the amplitude. The period. Remember that cosine and sine, their period is equal to 2 pi. And because we have a B is going to mess with that period. It's going to change it. B makes the period either longer or shorter. Okay? How we figure that out? There's a formula. For period equals 2 pi divided by B. Okay? So all we're going to do is go over here. We know that our B value is 7. So our period will equal 2 pi divided by 7. And then you need to make sure that if there's any reducing, reduce it. Okay? There is no reducing, so now you know the period. It's gotten shorter. Our period will happen 2 pi over 7. Every 2 pi over 7, the distance of that is a new wave. So if we kind of go over here and look, oh, this is 2 pi over 7, even though they just put the pi out to the side. The pi is really in the numerator, and so is this guy. So now our answer is either B or D. You got a 50-50 shot now, okay? Because both of these have a period of 2 pi over 7. All right, so the last piece then is all about that phase shift. This guy is our phase shift, the number that is being added or subtracted to x, okay? So the phase shift is a positive 5/7. We don't put negative down because in the original formula, it is subtraction. So whatever you write down for the phase shift, whatever number you see up here, think the opposite when you write that down. D represents the phase shift. Okay? So whatever number is right here, it looks like negative 5/7 in the phase shift. Give me the opposite of that. Okay? Think opposite. All right? And when we go back and look at this, D is the only answer that is acceptable. Okay? All right. So down below here, so here they want to talk about the period, the amplitude, and then they want to know which picture represents that graph. Okay? So let's do that. Again, we're still in 9-3. Still in 9-3. So question number 9. Y equals sine 1/6 x. So they made things easy for us. There is no phase shift and there is no vertical translation. Okay. So they want to know what is the amplitude. Well, what is the number in front of sine? You don't see one, but the default will be 1. So the amplitude is 1. That means our wave will go up to 1 and down to -1, up to 1 and down to -1. It will oscillate back and forth between there. Okay. The period, we just talked about this. We got that little formula. P equals 2 pi, because sine and cosine have a period of 2 pi, divided by our B. Well, what's the number in front of x? We don't have to worry about GCF in this one because there's no adding and subtracting going on. Okay. You don't have to worry about that. There's no phase shift. Only worry about pulling out GCFs and modifying if there's a phase shift. So in here, so our B is 1/6. So if we adjust that, you end up finding out that your phase shift, or sorry, not phase shift, our period is 12 pi. So we need a function that takes a long time to go. It'll go up and down, and that distance will be 12 pi before it starts again. Okay? So in our blanks over here, we'll put we'll put 12 pi here, and then down here you'll put an amplitude of 1. So if we come down here and look at things, really you just got to pay attention to what's going on. So if you look at these, A and C are the only ones that stretch out to 12 pi. Okay? So it's either A or it's C. The real answer is C, because you have to remember that sine graphs, I should say specifically, start at the origin and travel up first. Trying to think about how I want to do that. So they'll start from the origin and they'll travel up and then travel down. So up, then down. So if you look at this guy travels down first, then up. That would be the reflection of the sine graph, okay? So this would be if we had a negative amplitude. It would start down, then go up. This is the one we want, because notice it starts at the origin and it goes up and then down, okay? So the answer is C for your graph. And there we go. All right, moving on. Our next question, number 10. Okay, so number 10, this is where you will actually be filling in the graphing tool. So when you're in MyMathLab and you click on this, the graphing tool will pop up and you got to fill in the amplitude, the phase shift, the vertical translation, the period. You fill in all that piece of information. Make sure that you select the correct graph according to whether it's sine or cosine. Because again, we're still in 9.3. And then it will graph. Now I'm going to be doing this by hand, so I'm going to be showing a lot more work. But in yours, I will highlight the pieces that you need to adjust in the MyMathLab screen that pops up when you click on the graph. Okay, so we've got y equals 4 cosine parenthesis x plus pi over 10. Okay, so let's talk about how we graph this. So since we do have a phase shift in here, okay, since we do have a phase shift, I want to modify this so it looks like what we talked about in question number 8. So I'm going to pull out a GCF. And the GCF will get the number in front of x, and that number will be a 1. And if I pull out a 1, that's really not going to change anything, but I want it to look like that format that we talked about. So this is now my B, and then this is my D over here. So now we know everybody for sure, okay? Because this looks like the format that we talked about back in question number 8. So let's talk about the amplitude, because we need to know about that. So what is my A? It's 4. Again, in this one, your amplitude, if this number was negative, that means you would have a reflection over the x-axis. Okay, and there would be a box in this MyMathLab screen at the bottom of it. There are 2 boxes, reflect over the x-axis, reflect over the y-axis. So if this A was negative, you would have to check the box for reflect over the x-axis. You should never, ever check the box reflection over the y. We're not going to use it. Not once did you have to deal with it in your assignment. So make sure that if your A is negative, check the box that says reflect over the x-axis. Okay? But Our problem, this is not negative, so there is no reflection, and the amplitude is purely 4. That means our graph will go up to 4, down to 4, up to 4, down to -4. I know we said down to 4 a moment ago, but then down to -4. Okay? So we now know, if I kind of like draw a makeshift graph, we are going to go, this is a horrible graph. What am I doing? That's a little bit better. Up to 4, down to 4. Okay? And this is one of those numbers that you would be putting in those boxes. This is one of the things you have to answer because it will ask you what is the amplitude. The next one, let's talk about the period. Okay? So the period of this guy will be whatever this one is. Okay? So the period, remember, in order to find the period, because it's cosine, we're going to take 2 pi divided by b, which is 1, because that's the b. So 2 pi divided by 1 is 2 pi. So we haven't changed the period. So in that little toolbox that pops up on my math lab, you will tell it to keep the period at 2 pi. There is no vertical translation, okay? There's only a phase shift. So the phase shift, well, what is the phase shift? Well, here's the number. Remember, you have to give me the opposite of what you see. So that means the phase shift is a -10 or pi over 10. In other words, what this really means is my graph is going to move to the left pi over 10. That's really what the phase shift means, because phase shift is horizontal movement translations. So this is a piece you have to fill in. And then the other piece you have to fill in is the vertical translation, which I just talked about, which is 0. There is none. So these are the 4 pieces. Know that you might have to select that box that says reflect over the x-axis, but we do not select it because that is a positive value. Our amplitude is positive. So these are the pieces you have to answer. And then from there, it will make your graph. Now remember, it's cosine. Cosines start at the amplitude, okay? So when you're in there, you have 2 pictures that look like this. One starts down, goes up like that. The other picture looks like this. So it starts up, goes down, and then goes back up. If you hover your mouse over these pictures, it will tell you which function it is. But you should know that this is the sine function. This is the cosine function, because cosines start at the amplitude, sine starts at the origin. Okay? All right. So if I draw this graph so you can kind of get a picture of what's going on, I have a little bit of side work that I do, but really what's happening is we're taking this normal graph that would have started up here, went down and back up, and we're going to just move it to the left, -pi over 10, or actually just pi over 10. So that means our graph is actually going to start right down here at -pi over 10. Okay? And our graph will end at -19 pi over 10. Again, you don't have to worry about where I'm getting these numbers from. I'm just letting you know what kind of like what it's going to look like. Okay? So it will end at 19 pi over 10, because when you put all this information in, it's doing all this calculation that I'm kind of doing here. Okay? So doing a little bit more calculations to help me kind of graph some things here. Sorry, I forgot what I was doing for a second. The middle of my graph will happen at 9 pi over 10. So just bear with me, doing a little bit of math. I'll have another piece right over here at 2 pi over 5 and plus 9 over. Just figuring some things out. You do not do this work. This is purely stuff that I had to do. And I will have another piece over here at 7 pi over 5. So this is just to help me graph. So the graph will start up here because it's a cosine. When you click on this, it'll start at the amplitude at negative pi over 10. It will go down to the x-axis and cross it at 2 pi over 5. It'll go down to the amplitude at negative 4, at 9 pi over 10. At 7 pi over 5, it'll hit the axis again. And at 19 pi over 10, it'll be back up at the amplitude. So your graph will look something like that. Okay? Again, this is the information that you're filling in. And this is the graph that you make sure that you choose once you fill in all that information there. Okay? The computer, my math lab, does all the graphing for you. Okay, but I had to do a little bit by hand so I can show you what the graph looks like. This is kind of like the longest problem right here. Okay? All right, so there's number 10. This is the graph that should kind of display in a way. All right? Moving on, I believe we should be hitting 9.4 now. Let's double check. Yep, 9.4. So 11 and 12 are all 9.4. So again, in here, we're going to talk about cosecant and secant graphs. So 11 is 9.4, and so is 12. Okay? So let's talk about this. Y equals negative 4 cosecant x. How I approach this, cosecants and secant graphs look like a bunch of quadratics put together, okay? So when I look at this down here, I know that my answer is between A and B, okay? I know my answer is either A or it is B, okay? Because this graph represents a sine or a cosine graph. This graph down here is tangent or cotangent. So right away, I can narrow my choices down to either A or B, okay? Now, here's how I think about this. When I deal with cosecant secants, I pretend that they are sines and cosines. Sines and cosines. Okay? So when I look at this and I think to myself, who is the reciprocal of this? It's a sine. So I pretend that my graph is this. And I graph a sine graph, and then all I got to do is take the wave and cut it and flip them outside. You'll see what I mean here in just a second. Okay? So, cool thing in this one, we're only messing with the A. We're only messing with the amplitude. So that amplitude tells us that we need our graph to be up at 4 and down at a negative 4. And right here, notice that my A value is negative. That also means that if I could check the box for a reflection over the x-axis, I would. Because it's negative, that means we are reflecting over the x-axis, okay? So let me show you what I'm talking about here. So because I didn't change anything, my graph will look like this so far. This is pi halves, pi, 3 pi over 2, 2 pi. 4, -4. Now, normally sine starts at the origin and then goes up and then goes down and back up. So that's the normal sine graph. But what have we done is we have reflected over the x-axis. So sine will still start here at the origin, but it will travel down first, then back to the axis, then to the positive amplitude, and then back to the axis. And this is what the sine graph looks like. Now notice I'm dotting it in because this is not really the graph we're after. What we're after is the cosecant graph. And in cosecant graphs, you have what we call asymptotes. Anywhere where the sine graph crosses the x-axis, that's an asymptote. So this is an asymptote right there on the y-axis. This is an asymptote right here at pi. This is an asymptote right here at 2 pi, okay? Now, notice that when I've drawn in those asymptotes, it's cut my graph. I have this little kind of quadratic right there, and I have this quadratic. Remember that sine is a reciprocal of cosecant. So reciprocal just means flip it. So flip these. So if I flip those little quadratics, boom, this is what the cosecant graph looks like. Okay? So we just need to find the graph that matches that. So if we come back here, right here, the answer was B. Cool beans? Yes. Good. I'm glad you agree. All right. So there's question 11. And then question number 12 is all about tangents. Okay? So 9.4, this is the last 9.4. This is the last like graphing. I know graphing was kind of a pain in the neck in here. Believe me, I know, I teach it. So we've got -2 minus tangent x. All right. So let's talk about this. Okay? So cool thing is we're not doing a lot of messing around with. We're going to keep the period the same. We're not shifting left or right, but what we did do is we do have a vertical translation here. Okay? So, and we have the amplitude that we're dealing with. So in here, we're dealing with a vertical translation and the amplitude. So if we talk about the amplitude for this is 1. Okay? You'll understand why. And it's not really kind of like an amplitude, but we like to, you'll see why I call this the amplitude. All right? And then over here, we have a vertical translation. So this guy right here, because it is a -2, means that your vertical translation really is a -2. It just means that we're going to take the normal tangent graph and we're going to move it down 2. Okay? We're going to take that normal tangent graph and move it down 2. All right? So now that we know what's going on, oh, I almost forgot. Notice that your A value is negative. So again, down at the bottom, you would be checking that box that says reflection over the y-axis. Okay? Sorry, not y-axis, x-axis. Woo! Mr. Armstrong, what are you doing? Over the x-axis. So if I draw a quick graph of this, so you know, tangent and cotangent graphs, they look like cubic graphs, okay? Now, what's interesting about tangent is tangent graph actually starts over here at negative pi over 2 and ends over here at positive pi over 2. Because tangent graphs, they have a period, tangent and cotangent, they have periods of pi. And we didn't mess with that, okay? But this is a period of pi for tangent because half pi and half pi, if added together, give you a full pi. All right? Now, at this beginning and end piece right here are your vertical asymptotes. Okay? And then in here, I've got 3 other marks. This is negative pi over 4. This is positive pi over 4. Okay? And then 1, 2, 3. 1, 2, 3. Yeah. So 1, 2, negative 1, negative 2. So what's happened is that a normal tangent graph looks like a cubic. So cubic graphs start down here, and it would have hit negative 1 at negative pi over 4. It would have hit 0, 0, and then it would have hit positive 1 at pi over 4. And it would be a cubic graph that goes, woo, just like that. But what we did is we just took these points and we moved them all down 2. Okay? So this origin point shifted down 2, 1, 2. This negative pi over 4, negative 1 point shifted down 2, 1, 2. This pi over 4 comma 1 point shifted down 2, 1, 2. So my cubic looking tangent graph looks like this. And these points right here, these are acting like what I call the amplitude. See how from the origin it is a distance of 1. It is a distance of 1. If my amplitude was 2, then I would have moved, I would have adjusted so that there would have been a distance of 2 between these and 2 between these, okay, if the amplitude was 2, just so you know. But there it is. This is what the tangent graph looks like, okay? And I messed up because I forgot the most important piece. This is what it looks like if it didn't reflect. So we need to actually perform the reflection of the amplitude. I almost forgot that, and that's important. See why I say graphing can be a mess? So remember that this point was down here after it moved down 2, so a reflection would put it right over there. This point was up here, and a reflection would put it right here. It just reverses the cubic graph. So this is what we're looking for. I know that part looks a little horrible. I'm going to fix that because I'm kind of a perfectionist. All right. There we go. So that's really what the picture looks like. And if we go into our graph, so we need something that's over. So see how this is at negative pi. This is at negative pi. We know it's not these two because it has to start at negative pi over 2. So A and B are out. So it's one of these two. So which one looks like it has reflected over the x-axis? And it's going to be C. Okay? C is our graph that we have. Because this is a normal tangent graph that has been moved up 2. This is the tangent graph that has been moved down to and reflected. All right. So there, that ends graphing. Let's get out of graphing. Done with graphing. All right. Whew. 13 starts 9.5. And 9.5 is a lot like 9.2, except we are no longer on the unit circle. Our circles can be of any size they want. Okay? On the unit circle, your radius was 1. In 9.5, our radius of our circle could be anything. So when I taught this, I usually called 9.5 9.2 part 2, okay? Because it is just like 9.2, except again, we're not on the unit circle anymore. So we got to think about some other things. So the first things first, it says sketch an angle in standard position such that theta has the least possible positive measure and the point is -2, 0. So they want to know which graph down below has the point -2, 0 graphed and shows a counterclockwise rotation. So the graph that shows -2, 0 is C. So there's your graph, because that's the one that has the point -2 graphed, and we're going in a counterclockwise rotation. Okay. Now down below that, we want to answer all of the sine thetas, the cosine thetas, the tangent thetas, cosecant theta, secant theta, cotangent theta. Now, let's talk about this because we are not on the unit circle. And remember that our point is -2, 0, which is still important to us. But remember, when we are not on the unit circle, we got new trig functions where sine is equal to y over r, where r is the radius of our circle. Before, we didn't worry about this because we were on the unit circle and your radius was always 1. But now, since our circle can be any size, we have to have r there. Cosine still deals with the x, but it's x over r. And tangent is all about y over x still. Okay? To get cosecant, secant, and cotangent, just flip these. All right. So in order to find our values up here, we need to find the radius. Okay. We need r. And there's a formula. The radius is equal to the square root of x squared plus y squared. It's like the Pythagorean theorem. Okay. It's like the Pythagorean theorem. So all you got to do is plug in. We want to know what is the answer if we take -2, square it, add it with 0 squared. Okay, and when you all is said and done in your calculator, you find out that the radius is 2. So now we can find all our trig functions. We just got to plug in. Easy peasy. So y over your r, which is 2. So that is 0. Cosine is your x, which is -2, over your r, which is 2. So that answer is -1. Tangent is your y over your x. So that is 0 over -2, which is 0. All these guys are going to be the reciprocals. So the reciprocal of 0, we talked about that, undefined. The reciprocal of -1 is still -1. And the reciprocal of 0, again, undefined. And all of these answers make sense because if you look at this picture, that's a quadrantal angle. Okay, and if we were on the unit circle, that would have been -1, 0, which were all the same answers. And that makes sense because -1, 0 and -2, 0 have the same angle measure, 180 degrees. So it makes sense that all their answers are the same because in trig, we talk about that angle. Okay? Cool beans. All right, so the next one, we're going to find these trig functions based off of what we know. Okay? So we know that tangent, and so this is 14, again, still in 9.5. 14, tangent theta is equal to -8/15. And they're telling us that our theta is in quadrant 2. And that's important information. Okay? So here's what we know. Well, what do we know about points in quadrant 2? Because this negative is out front. And remember, I told you that this negative, it can have other positions. It can either go on the top or it can go on the bottom. So the question is who gets the negative? We need to know that. And that's why we have this information right here. Because in quadrant 2, points are -x, y. Tangent, as we discussed in 9.2 and in 9.5, remember tangent is made up of y over x. Now we know who is really getting the negative. So when we look at this, tangent theta is really equal to 8 over a -15 because the x value has to be negative and the x value is in the bottom, which now also means we know what the point is. We know the point is -15, 8, which we can now solve for r, because that's what we're going to need in order to get the sine theta, the cosine theta, the cosecant theta, secant theta. Cotangent theta should be really easy. All we do is we just flip this. So cotangent theta is just the reciprocal of what we already know. So that'll be -15/8. So that one's already good to go. But to get these guys, we got to have r. So again, we plug into our equation, -15 squared plus 8 squared. I was about to write 64, which I was thinking ahead. Silly me. 8 squared. So just so you know, whenever you do this, big rule of thumb, you should always get a positive number under this radical. You should never ever have a negative number under this radical. And the answer for r will always be positive, okay? You'll never ever have a negative radius. That's just weird, okay? Because the radius is the distance of your circle. So 15 squared is 225 plus 64. So 225 plus 64 equals 289. And I believe we can actually take the square root of 289. Yep. So our radius is 17. If that gave me a decimal answer, you would need to reduce the radical. Okay? But we don't have to reduce, so it's all good. So now all we do is plug and chug. So sine is equal to y over r. So that's 8 over 17. Cosine is equal to x over r. So that's -15 over 17. Cosecant is the reciprocal of sine. So that's 17 over 8. Secant is the reciprocal of cosine. So that's 17 over -15. And there you go. All right, number 15. So we are now jumping into 9.6, where we learned about Pocahontas' sister, Sokotoa, okay? Or Sacagawea's cousin, Sokotoa. Either way, they're all related. So we've got SOHCAHTOA here. So they're asking us to find the right triangle trig for the given triangle over there. So we got this right triangle. We got 45. We got 28. I'm just copying it down. And we know that this is angle A in that bottom left-hand corner. So we are looking for all of the information to sine A, cosine A, tangent A, cosecant A, secant A, and cotangent A. Okay? So this is your base angle. We have this word SOHCAHTOA, which separate our three trig functions. So remember, O, H, and A stand for opposite, adjacent, and hypotenuse. As I told you in the videos, or as you should know, the 53, because this is the largest side, is the hypotenuse. Or remember that the largest angle is across from the largest side, and the hypotenuse is always across from that 90 degrees. Okay? Now, based off of this angle, remember that I told you in the videos that this angle, which we're going from, is made up of the adjacent and the hypotenuse. Well, if this side is the hypotenuse, that means the 45 has to be the adjacent, because the adjacent and the hypotenuse make our angle. And that leaves you with the 28 being the opposite. So when you're running SOHCAHTOA, you have to know who your base angle is. Where is home base? Where is headquarters? And then you list everything out according to that. So it says sine is the opposite over the hypotenuse. So the opposite is 28. The hypotenuse is 53. And you should always make sure that that doesn't reduce. So we hit alpha, y equals. And so we got 28 over 53. And that is the final answer. So since that didn't reduce, I don't have to worry about the rest of the fractions because they won't reduce either. Cosine is equal to the adjacent over the hypotenuse. So the adjacent is 45. Hypotenuse is 53. So there we go. And I don't have to worry about reducing that. And tangent is equal to opposite over adjacent. So the opposite is 28. The adjacent is 45. Now that we got the big three, all we do is flip, flip, flip to get the other ones. So cosecant is the reciprocal of sine. So that's 53 over 28. Secant is the reciprocal of cosine. So that's 53 over 45. Cotangent is the reciprocal of tangent. So that's 45 over 28. And there you go. Little bit of SOHCAHTOA. All right, next question. What is it? 16, I think. Moving on. So 16, it wants us to find the exact value for this expression. So cotangent pi over 6. This is coming from 9.6. So the next few, they actually want us to find the exact expression. So when we do exact expressions, I don't know what every professor is doing, but kind of give you a glimpse of what I am going to do. Well, no, it's not there. For my class, I'm only giving my students quadrant 1 of all the trig functions because I expect them to know reference angles and the little acronym ASTC. All students take calculus, which tell you about the sign of your trig functions. Okay, I don't know what your professor is going to allow you to have or not, but my students are at least getting quadrant 1, because if you know quadrant 1 trig functions, you know everybody else. Okay, so when you're dealing with finding an exact value, like what we have right here, the first thing you need to do is you need to make sure that this is the least positive coterminal angle. Okay? So you want to make sure that this angle is between 0 and 2 pi, since we're in radians. Again, if you want to convert this into degrees and work this, that's absolutely fine. And you don't have to worry about converting it back later on. Okay? You can work this all in degrees if you wanted to. All right. So is this number between 0 and 2 pi? Absolutely. So we already have the least positive coterminal angle. The next piece you want to find is the reference angle. Okay? So the reference angle, that needs to be an angle between 0 and pi over 2. Because we're going to relate it back to quadrant 1. That's why quadrant 1, knowing that, is so important. Because if you know quadrant 1, you know everybody else. Because whatever the answer to this is in quadrant 1, it's the same answer that's got to be out here. You just got to check the sign. So is pi over 6 between here? Absolutely. So this angle actually is the reference angle as well. That makes things a whole heck of a lot easier for us. If it wasn't the reference angle, then you would have to look at your chart. So if you're in quadrant 1, you already are the reference angle. If this angle was in quadrant 2, you would take 180 degrees minus that angle, or in other words, pi, if you're in radians. If you were in double checking something. Yeah. If you were in quadrant 3, you would take your angle minus 180 degrees. And if you were in quadrant 4, you would take 360 degrees minus your angle to figure out the reference angle. And again, 360 degrees would be 2 pi, 180 would be pi. So these are how you figure out your reference angles if you're in quadrant 2, quadrant 3, or quadrant 4. But our angle was already in quadrant 1. So it is the reference angle. So that makes it easy. All you got to do now is go consult your chart and look at what cotangent pi over 6 is. So like I said, my students only get the basic trig chart. So cotangent of pi over 6 is, looking it up because I don't know off the top of my head, there it is, square root of 3. And then the last thing you would want to know is, what is the sign of this? Well, remember, so cotangent pi over 6 is the square root of 3. And then remember, all students take calculus. That's what's going to tell you the signs. And that's my last step. Okay? So first you find the least positive coterminal. I've got that backwards. So find the least positive coterminal angle, and then find the reference angle, and then with using your little chart right there, and then you're going to find the sign. And since we are in quadrant 1, A for all means everybody's positive. So this answer is good to go. Okay? Question number 17 is going to be just like this. So let's take a look at it. So in here, I put the square root of 3. So here we want cosecant pi over 3. Okay? So if we come into our notes, so least positive coterminal angle. So is this between 0 and 2 pi? Absolutely. Check. Is this the reference angle? Yes, absolutely. It's in quadrant 1. So reference angle. Check. So all we need to do then is figure this out. and then we can deal with the sine. Okay, so since this is in quadrant 1, this is the reference angle, let's figure out what cosecant pi over 3. So you go to your little trig chart, and cosecant pi over 3 is 2 square root of 3 over 3. And because this is in quadrant 1 already, the answer is going to stay positive because everybody in quadrant 1 is all positive. Done. All right, number 18, moving on. Easy peasy, we got this. Number 18 is 9.6, and it's just asking you about a cofunction. So who is the cofunction of sine 72 degrees? Well, sine 72 degrees, what it means by cofunction, it means that if I'm looking at a right triangle, there we go, and this is 72 degrees. They want to know if I went from the angle over here, who would be the same as sine 72? Remember, sine is made up of the opposite and the hypotenuse. But if I'm at this angle, that means this guy is the adjacent, and that's still the hypotenuse. So who is the cofunction for sine 72? Well, it will be the adjacent and the hypotenuse. So that will be cosine. And then what is this angle? Well, you're going to take 90 degrees minus 72 degrees. And so that will give us cosine of, let's see here, 18 degrees. That's the cofunction. And if you go to your calculator, you can even check this. They should have the same answer. Sine, and we are in degrees. Always good to check your calculator when working with things. Sine 72, enter. Cosine 18, enter. Same answer. That's why they call them cofunctions, because they provide the same answer. Just this angle is 72 degrees, and this is coming from another angle, which is 18. Okay. All right. So cofunction done. 19, all about reference angles again. No biggie. All right. So 19. Again, 9.6, we are still in. All right. So we need the reference angle for 7 pi over 4. All right. So first, is 7 pi over 4, again, before we get this guy, we got to make sure that is the least positive coterminal angle. Okay? And 7 pi over 4 is the least positive coterminal angle. It is between 0 and 2 pi. So now we're going to find that reference angle. And remember that I wrote down that chart right over here. So this is that reference angle chart. What quadrant is 7 pi over 4 in? It's in quadrant 4. So in order to get my answer, I need to take 360 minus that angle. In order to get that reference angle, I need 360 minus that angle, okay? Or in other words, since we are in radians, I'm going to take 2 pi minus 7 pi over 4. So the reference angle is 2 pi minus 7 pi over 4. And again, just like what we did at the beginning, all that you're really doing is subtracting fractions. You're taking 2 minus 7 fourths. Okay? So we go to our handy dandy calculator. 2 minus alpha y equals 7 fourths. And your reference angle is pi over 4. So all the answers for this guy, if we were looking at trig, would be based off of pi over 4. Okay? All right, so now it wants another reference angle. All right, so we just did that. Easy peasy. So again, 9.6. And we are looking for the reference angle of negative 4 pi over 3. So first things first, we need the least positive coterminal angle. So this is definitely not the least positive coterminal angle. So what we need to do is we need to add 2 pi onto this until we finally get a positive number. So we're going to take 2 pi. Well, actually, we're going to take our angle, negative 4 pi over 3, and we're going to add 2 pi to it. Again, just fractions. I'm going to take negative 4/3 plus 2. Okay? Pi is just along for the ride. So run to your calculator. Alpha y equals negative 4/3 plus 2. So now we've got the positive, or I should say least positive coterminal angle of 2 pi over 3. There it is. Okay? So now we can start finding the reference angle. So the first question is, what quadrant is that one in? So we knew this guy was quadrant 4. That's how we got to this little equation right here. So for this guy, it is in, we got to look at where is 2 pi over 3. And 2 pi over 3, that's in quadrant 2. Okay? Again, if you don't like looking at these in radians, change it to degrees. Okay? But in the end of this, you will have to turn it back into radians because the answer is a reference angle in radians. So now that we know that we're in quadrant 2, to get the answer, all we're going to do is take pi minus that angle. So we're going to take pi minus 2 pi over 3. And again, it's just fraction work. You're taking 1 minus 2/3. That's what's going on. And if you take 1 minus 2/3, you get pi over 3. There's the reference angle. All trig functions for this guy, the answers are going to be according to pi over 3. Okay? All right, so number 21. We're going to put all that to use. Number 21 and number 22 are just like what we did for questions. Oh gosh, where did you go? They're just like what we did for questions 16 and 17. 21 and 22 are just like questions 16 and 17. Okay? So 21, again, this is all 9/6. So we've got this angle, and we want to know what is sine of 100 or 1,410 degrees. Cosine of 1,410 degrees. Tangent of 1,410 degrees. And then we've got cosecant, 1,410 degrees. Secant, 1,410 degrees. Cotangent, 1,410 degrees. Okay. So let's jump over to my page. First things first, we got 1,410 degrees. We need the least positive coterminal angle. So all we're going to do is keep subtracting 360 until we get there. So 1,410 minus 360 is 1,050. Not there yet. Minus 360, 6,090. Still not there yet. Subtract another 360, 330 degrees. Now we're there. That is the least positive coterminal angle, because if I subtract another 360, I'm negative. Now we need to find the reference angle. Well, this is obviously not the reference angle because that's not in quadrant 1. So we know that this angle is in quadrant 4. And we've already talked about how to find the reference angle in quadrant 4. You just take 2 pi, or in other words, this case it's 360 minus our angle. So we're going to take 360 degrees minus 330 degrees. And when you subtract that, our reference angle is 30 degrees. So all these answers are going to be based off of 30 degrees. So whatever happens at 30 degrees for these, those are your answers. And then we just have to look at the signs. Okay? So sine of 30 degrees is what half? Sorry, I was looking at my sheet over here on the side. Cosine of 30 degrees is square root of 3 over 2. Tangent of 30 degrees is the square root of 3 over 3. Cotangent is just the square root of 3. Cosecant is 2. And secant is 2 square roots of 3 over 3. Now the last thing you got to do is to check the signs. We are in quadrant 4. In quadrant 4, we have the letter C. Okay? In quadrant 4, we have the letter C. C means that cosine and its reciprocal, which is secant, are positive. Everybody else is negative. So these two answers are good. Everybody else is now negative. And you're done. Those are all the answers for sine, cosine, tangent, cosecant, secant, and cotangent of 1,410 degrees. You only need quadrant 1. Okie dokie, let's jump into number 22. So 22 is just like what we just did. Coming from 9.6. Okay. So we want the exact value for all these trig functions. Okay. So sine of negative 3 pi over 4. Cosine of negative 3 pi over 4. Tangent, negative 3 pi over 4. Cosecant, negative 3 pi over 4. Secant, negative 3 pi over 4. And cotangent, negative 3 pi over 4. All right. So just like last time, negative 3 pi over 4. We need the least positive coterminal. So we're going to add 2 pi until we get there. Okay, and we actually only have to do it once. So if we take, again, we're just working fractions. You're going to take alpha y equals negative 3 over 4. Scroll out to the side, plus 2. So our least positive coterminal angle is 5 pi over 4. Okay? Reference angle. Well, in order to find this reference angle, we need to know what quadrant it's in. And this is actually in quadrant 3. Okay, so in order to find the reference angle in quadrant 3, you will take quadrant 3, the angle minus 180, or in our case, minus pi. So we will take 5 pi over 4 minus pi. Again, that's just fraction work. 5/4 minus 1, which actually gives you the reference angle of pi over 4. So all of these are going to be based off of pi over 4. 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 And we know those answers. So let's find them real quick. Sine of pi over 4 is the square root of 2 over 2. Cosine of pi over 4 is the square root of 2 over 2. Tangent is 1. Cosecant is 2, no, just the square root of 2. Secant is just the square root of 2. Cotangent is 1. And then now you worry about the signs. Since we are in quadrant 3, there is a T in that quadrant, which stands for tangent, and its reciprocal cotangent are positive. So these answers are good to go. Everybody else, tack on a negative to those answers. Some of this looks horrible. Let's fix this. So just tack on a negative to your answer. And you're done. Again, you only need to know quadrant 1. Okay? All right, 23 is still 9.6. This is the last one. So there's a lot in here from 9.6 because it covered a lot. So 9.6, if I go back through, look at our notes, 9.6 started with question, I think it was 16? Nope, 15. All the way through question number 23. So 9.6 is from 15 through question 23, because there's a lot of information in there. So once we get to number 24, we're in the last section, which is 9.7. So here, all they want to know is, what is the decimal approximation for secant 39 degrees, 12 minutes? All right. Well, if you try to go to your calculator, you will notice there is no secant on here. Sine to the -1s, cosine to the -1, tangent to the -1, those are not reciprocal notations. This means inverse, okay? We only use sine inverse, cosine inverse, tangent inverse when we're looking for angles. So when we look at this problem, we can't put secant into our calculator, but what we can deal with is its reciprocal, because the reciprocal of secant is cosine. So I can put cosine in my calculator. So remember, this is the reciprocal of cosine. So we can take 1 over cosine 39 degrees, 12 minutes. Now that we can put it into our calculator. And if we go back, we got to make sure that we look at this. It says round to 8 decimal places. So we need 8 decimal places. So we're going to go to our calculator. Alpha y equals 1 over cosine. And then we're going to put 39. If you hit second apps, there's your angle symbol. And then 12 minutes. So press 12, not 11. 12. Hit second apps. Right there is the minute sign. Enter, close, scroll out to the side. That right there is secant 39 degrees, 12 minutes. We need 8 decimals. So this will be 1.29041501. That is all the decimals because that's 8 decimal places. See, look, 1, 2, 3, 4, 5, 6, 7, 8. So that right there on your calculator is the answer they want you to put into the blank, because that is 8 decimal places. Let me make sure that said 8 again. Yep, round to 8 decimal places. So you're all good. All right, last 2 questions. So 24 and 25. Sorry, I didn't mean to scroll down. You can see the answer key is there, but I'm going to post this answer key out there for all of you anyway. So 24 and 25 come from 9.7. So 24, all they want you to do is demolish the triangle. Solve for everything, all sides, all angles. Make sure that you pay attention to the rounding, okay? But we want you to solve for all the sides and all the angles, okay? So now that I have everything written down, so it says the angle is rounded to 1 decimal place and the side lengths will be rounded to the nearest integer, whole number. Okay, easy peasy. So in order to find the measure of angle M, all we're going to do, remember all the angles inside a triangle add up to 180, right? Or just remember that these 2 angles have to be complementary. Complementary means they add to 90. So to get angle M, all I'm going to do is take 90 degrees minus 50.2 degrees. Okay? And if I subtract that, I think that's 39.8, just making sure. That mental math sometimes kicks our butt. Yeah, 39.8 degrees. So there's the measure of angle M, and it's rounded to 1 decimal place already. So it's good to go. All right, now to find the other 2, we're going to use SOHCAHTOA to help us out with those. Okay? So, and I'm going to go from the angle that's given. So according to this angle, P is the hypotenuse. The 125 meters is the adjacent. N is the opposite. So we're going to run SOHCAHTOA twice. Okay? So if I want to solve for N and I want to use the 125, I don't want to use P. That would be really silly. If I use N and P, that's 2 unknowns. I only need 1 variable in my solving. So I want to use N and the 125. So that's the opposite and the adjacent. So in order to solve for N, I'm going to use tangent 50.2 degrees equal to the opposite, which is N, over the adjacent, which is 125. That's how I will solve for N. And then now I'm going to look at SOHCAHTOA again. So in order to solve for P, that's the hypotenuse, and I want to use the 125, okay? So that's adjacent and the hypotenuse. That's cosine. So I will use cosine 50.2 degrees, which is equal to 125 over P. So those are the 2 that I'm going to use to help me solve. I won't use sine because, as I said, sine will give me N over P, and I don't want 2 unknowns. So all you do to solve this, these are just proportions. This is just a number over 1. This is just a number over 1. So let's cross multiply. 1 times N is N equal to, all we're going to do is take 125 times tangent 50.2 degrees. So when we go to our handy dandy calculator, take 125 times tangent 50.2. And that is an angle measure in degrees, and we are in degrees, so we're good to go. Enter. to the nearest whole number or integer would be 150. So n is 150 meters. There we go. 150 meters. Over here, cross multiply. So that's cosine 50.2 times p equal to 1 times 125 is 125. How do I get p by itself? Divide by this number. This is just a number. If you go to your calculator and type cosine 50.2, it's going to give you a number. Okay? This is like if I had 2p here. How do I get rid of the 2 in front of the p? I would divide by 2. We can divide by trig. Again, this is just a number. It's like pi. Okay? So we're going to divide by cosine 50.2 degrees. We're going to divide over here by cosine 50.2 degrees. And so now P will equal, go to our calculator, alpha y equals 125. I need a 1 there, Mr. Armstrong. 125 over cosine 50.2. Close it, got to the side, enter. To the nearest integer, P equals 195 meters. And now we have all the answers. Measure of angle M is 39.8 degrees. Measure of angle, or not angle, the side length of N is 150 meters. The side length of P is 195 meters. There we go. We've demolished the triangle. We know everything about it. Last but not least, number 25. Woo! We made it! Number 25, 9.7. All they want us to do here is solve for a certain piece of information, and they're throwing the vocabulary at you of angle of elevation. So it says, suppose you are headed towards a plateau, okay? 70 meters high. All right. So what we're looking at, this is me. And whenever I do these kind of problems, I like to draw a picture. And I'm heading for this plateau. So here's all the grass. And woo, there's the plateau. Okay. It is 70 meters high. Okay. Now, back here, if an angle of elevation to the top of the plateau is 20 degrees, so angle of elevation means that as I'm looking over here at the plateau, the angle that I have to tilt my head to the top is 20 degrees. Now I know that, I mean, like, this is really, really huge. Technically, I would be really, really small in this. But that angle is 20 degrees. They want to know, how far am I from the base? They want to know how far this distance is. So hopefully you see your triangle. It looks like this. Kind of pulling it out so we can see it. That's the question mark. That's 70 meters. This is 20 degrees. That's what's going on. So here's what it looks like kind of in real life, although I would be giant. But down here, this is really the triangle you're looking at. So again, all we're going to do is use SOHCAHTOA. This is my base angle. This is the adjacent. This is the opposite. So that means we're running tangent. So tangent, 20 degrees, is equal to opposite, which is 70, over the adjacent, which is our question mark. Or call it X. It doesn't really matter. So we use cross multiplication. So that gives us tangent 20 degrees times the question mark, equal to 1 times 70 is 70. How do I get the question mark by itself? Divide by the number tangent 20 degrees. Divide by tangent 20 degrees. And we are, let's go back, double check something. It says round to 2 decimal places. Check that rounding. So we go to our calculator, alpha y equals 70 all over tangent 20. Enter. And 2 decimal places will be 192.32, and we are in meters. There you go. That is what I would put into the missing blank. And that is exam 1, module 1, chapter 9 in your trigonometry college course, MAC1114. You stay classy, trigonometry students.